Stanford University.
All right, well, welcome to Stanford CS193P. That's developing applications for iOS, winter of 2017. So today, our topic is to talk about custom views, okay, specifically the drawing side of having custom views. And this is going to be a more typical lecture than last time because I'll be doing some slides and explaining the concepts to you, and then I'll go into a demo that shows you how we do it all. So what is a view? A view is a subclass of UIView, which is in UIKit in iOS. And all it does is carve out or represent a rectangular area on screen. And that rectangular area defines a coordinate space that we're going to draw in and that we're going to get multi-touch events like pinches and swipes and all that stuff. So today, I'm just going to focus on the drawing side of that, and then we'll start talking about the gestures on Wednesday. So these views, these little rectangular areas, are put on screen in this hierarchical way. And that just means that the views have sub-views inside of them. Now, any given view can only have one super view. That's the view that it's contained in, but it can have any number of sub-views, so views made out of it. So, for example, in the calculator, we had, for example, stack view. Okay? It had a lot of sub-views, all the buttons that we stacked in it. In fact, some of the stack views had other stack views as their sub-views, and then those stack views had more sub-views, which were buttons or whatever. Okay? So that's how we build our UI, is this hierarchical collection of these rectangular areas. Now, at the very, very, very top, there's a special UI view called UI window class. We don't deal with that in iOS. In fact, the only time you would ever do anything with UI window is if you were building an app that maybe projected to a projector so that you had two screens, your device and then maybe some external projector or something, then you might care about UI window. But otherwise, it's all about UI view. Okay? All of our arrangement of the screen is all about how we arrange the UI views. Now this hierarchy, okay, these rectangular areas inside of rectangular areas, is almost always built in Interface Builder inside Xcode. Okay, that's how we built the stack view stuff. We dragged out a bunch of buttons and then we selected them and we said embed in stack view. Well, that wrapped it in there. But we can also build that hierarchy by dragging views out of the utilities, bottom of the utilities window there, inside other views. So you can do it by drag and dropping inside of other views. It is possible to do it in code, but usually we're doing it graphically. If you're doing it in code, the two main methods involved in building and destroying this hierarchy are add subview. Okay, add subview takes a view as an argument. You send it to the soon-to-be super view of that view. In other words, you ask another view, please add this other view as a subview of yourself. Now, when you're doing the opposite, taking some view out of the hierarchy, you don't send it to the super view, you send it to the actual view itself. Basically, remove yourself from this view hierarchy. So you send remove from super view to the actual view you want removed. Now, where does this hierarchy start? I guess you could say it starts in UI window, but for our purposes, we don't even pay attention to that. It starts at the top level view in that scene in Interface Builder. Okay, the scene that's controlled by our view controller, right? That rectangular area that we work in. There's a top level view that kind of is covers the whole space up there. And there is an important instance variable, property, in UIView controller. Okay, so all subclasses of UIView controller get this property. It's called view, and it's a UIView, and it's that top level view. And that's very important to understand that in an MVC, the controller always has this var, which points to the very top of that view hierarchy in its scene. Okay? This top level view is important because, for example, when you rotate, it's the thing whose bounds changes, that top level view. And you're going to learn a little later in the quarter that when the bounds of a view changes, there's a mechanism for offering all of its subviews an opportunity to change. So that's why when we rotate the device, that top level view changes from being tall and thin to being wide and less tall. And that causes all those stack views and everything else to start getting resized as well because they're all subviews of this top level view. Okay? If you were going to add views to the view hierarchy programmatically rather than dragging and dropping them, then you would need this view because it's the top of the entire view hierarchy, and you would kind of work your way down to find out where you wanted to put that view. But we don't otherwise actually look at this view much because we usually have outlets, right? IB outlets, like the display that points to the label. That gives us access to that label. That's all we want, so we don't have to go looking at the top level view and looking all down the views, okay? So, so this is important to know about, but surprisingly you don't access it that much. Okay, this view is automatically hooked up for you in Interface Builder when you drag out a view controller. It's just all magically hooked up. You don't have to worry about that. Okay, let's talk about initialization of a UI view. As usual, when you saw the lecture from last time, you probably realized, whoa, initialization has a lot of caveats when you're talking about initializing a class, right? Remember all those rules I was going through, required, convenience, inits, inheritance, all this stuff. So we try to avoid initializers generally as much as we can by doing all the things I talked about on Wednesday, like setting things equal or even using lazy or something like that. But if you can't avoid it, UIView has an interesting initializer situation. It has two initializers that you have to deal with. Okay, one of them, init with the frame as the argument, is the one that you would call if you're trying to create a view in code, which you'll probably never do in this class, okay? Because you're always going to use it, do it in Interface Builder with Xcode. But so that's the kind of in code one. And then init with this coder thing, which I'll talk about right at the end of class, but it's not important to know early on. That's the init that gets called when your stuff comes out of Interface Builder, right? When it comes from when you built it in Xcode. All the stuff that you're building in Interface Builder essentially gets coded, that's what this coder business is about, gets coded into an XML file, kind of freeze-dried. And then when you run your program, that XML file gets loaded in, and it's kind of the instructions for how to create all those objects, okay? And init with coder is the initializer it uses to recreate the view. So if you have any code that needs to go in an initializer, like you need to initialize some var in your UIView, you have to do it like this. Okay, override both of these inits. One of them is a required init, the coder one. Okay, and create some other method like this green setup method I have, and just call that method from both of them. Okay, that way you're guaranteed that whether your custom view is created in code or created in Interface Builder, it will get initialized properly. Okay. If you have vars that have to be initialized, you may not be able to use this mechanism, of course, because you can't call methods in yourself until you're initialized. So you might have to have that var initialization be somewhat duplicated there. There's another alternative to initialization, though, and this is for any object that comes out of Interface Builder, which is called awake from nib. Okay, awake from nib. This is sent to every single object that ever comes out of Interface Builder file. Okay, that you edit in the storyboard there, including views and your view controller for that matter. And so you can do some initialization here, but it doesn't count as your object must be completely initialized. Those restrictions are not satisfied by this. But still you can put code in there to get going. And we're going to learn all kinds of ways to do initialization throughout our system down the road, but that's basically how you initialize UI views. Okay, so we're going to talk now about UIView as this rectangular area in which we're going to draw. And so to do that, we need to talk about some types. There's some very important types that you need to know. One of them is CG float. So CG float is a floating point value. All of your coordinates that you're going to be drawing in are all floating point values, but they're not doubles, they're not floats, they're CG floats. So this is a type, a real type, that you have to use all the time when you're doing anything with the drawing, okay? CG stands for core graphics. This is the graphics float right here, okay? There's also a CG point, which is just a struct with two things in it, X and Y. They're both CG floats. CG point represents a point in your coordinate system somewhere. Again, floating point coordinates. There's also CG size, which represents an extent, you know, with a width and a height, okay? Only it's just a struct with two CG floats, width and height, simple. And there's CG rect, of course, which is a rectangle. It's a struct that has an origin, which is a CG point, and an extent, which is a size. So a rectangle represents a size, okay? So creating a CG rect, there's actually quite a few initializers for it. You can create an origin and size, you can do X, Y, width, height, things like that. And CG rect also has a lot of really cool little convenience vars and funcs and things like that, like min X, max Y, mid Y. Those will tell you things like where's the left edge of your rect, the top, the left or the bottom, the middle points, etc. There's also nice functions like intersects other rect will return whether the two rectangles cross over. Right? And there's even contains whether a point is inside the rectangle, etc. So there's quite a few of these. I can't put them all on the slide, so you're going to want to familiarize yourself with CG rect because it probably has a lot of things in there that you would otherwise be writing your own code to do. Okay, so now that we have those types, those 4 types, we can start talking about this coordinate system that we're going to be doing our drawing in. Now, the most important thing to understand, the simplest thing, is that the origin of this coordinate system is in the upper left of the screen. Okay? It's not Cartesian coordinates, which the origin would be in the lower left of the screen, because in Cartesian coordinates, increasing y means up. But in this coordinate system, increasing y means going down the screen. Okay? So very important to understand that. So you can see that point I have up there, 500, 35, that's 500 over and 35 down from the origin upper left. Okay? Now, the units in here that we're drawing are points. Okay? Be very careful that you understand the unit terminology here. Okay? It's in points, not pixels. A pixel is like the smallest possible little light that can be turned on your screen. Okay? Now, some devices have a lot of pixels per point. Okay? They're very dense, and that's really great because if you're drawing smooth curves, like fonts are just smooth curves being drawn, you don't get jaggy edges because there's so many tiny little points. Okay? But we can't make it so that we draw in the pixel space. Otherwise, on a very dense pixel screen, our image would be really small. And in an undense one, it'd be really big because the pixels are really big. So we, instead of drawing in pixels, we draw in points. Okay? This is the same point, by the way, that is like the point size of a font, like 12-point font. We're same word there, same point. Okay? So you can find out, though, how many pixels there are per point, in other words, how high resolution your screen is, with this var in UIView called content scale factor. Okay? It's a CG float. It's either going to be 1, 2, or 3 currently, like the iPhone 7 Plus is 3 pixels per point in each direction. And the older, like iPhone 4S maybe, or maybe all the way back to 4 would be 1. Okay, some of the older iPads would be 1. The newer iPads would be 2. Okay, so if you're doing anything where you have to pay attention to the number of pixel points, this is what you need. Now the great thing is, most of the time you don't care. Because when you're using iOS to draw with a font, it's automatically going to do super smooth turns. So you don't even have to know what the scale factor is. Even if you're just drawing an arc, it'll make sure to do as little jaggies as possible. So you rarely have to know this, but actually, wake up, you do need to know for assignment 3. Okay? So assignment 3, you will have to know this. All right. Now, the most important var in all of UIView is this one, bounds. Okay? And even in that really important var, really what you care about is the size. Okay? This is, in your drawing coordinate system, the space you have to draw in. Okay? This is basically the size of your view in your own drawing coordinate system. So anytime you're doing any drawing and you want to draw something that's as wide as your view, you're going to use bounds.size.width here. Okay? And you're almost always going to have your bounds origin be 0, 0, so that if you want to put something in the upper left, you're going to put it at 0, 0 or close to 0, 0. You see what I mean? So this rect, bounds, is describing the area you have to draw in. Now, it's important because you obviously want to, depending on your size, draw yourself appropriately. Okay? And it's also important because there are 2 other vars that often get confused by students with bounds and which are quite different. Okay? That is frame and center. So frame and center have nothing to do with where you're drawing. Okay? That's bounds. Frame and center is where you are in your super view. Okay? So here's a picture of that, frame and center. So center is where your center is in your super view's coordinate system, and frame is a rectangle that completely encases you in your super view's coordinate system. And you might think, well, the size of my frame is going to be exactly the same size as my bound size, right? And the answer is no, because views can be rotated. Okay? And if you have a rotated view like this green one, view B, inside the code that's drawing in view B, its bounds just looks like a normal rectangle. The fact that it's rotated, it doesn't even know it's rotated. But if you look at the center of it, or if you look at the frame that encloses it, look, it's not the same size. It's big, it has to be bigger because to the super view, view A, view B kind of looks like a diamond, right? So it has to be bigger. So the bottom line here, never use frame or center to draw. Frame and center are only used to position you in your super view. Okay, and you can use either one. If you set the center, it'll move the frame. If you set the frame, it'll adjust the center. Okay, they're tied together. Okay, how do we create views? Okay, because I already told you we don't really use the initial, we don't create them in code very much. Okay, what we usually do is we drag them out from the object palette in the bottom of the utilities window, interface builder. But if I built a custom view, Paul's view or something, it's not going to be in the palette. Okay, the Xcode didn't ship with my view in the palette. So instead, there's a generic view, just plain UIView, and you're going to drag that in. But then you're going to inspect it using the top half of the utilities pane on the right. You're going to inspect it and change its class to not be UIView. It's going to be your subclass of UIView, so Paul view or whatever. Okay, and it's a very important step to remember. When you create a custom view and you drag it into your UI, you have to change its class to be your custom class. And we'll see that in the demo how it works. When you create it in code, of course, you're just doing UIView, subframe, and you provide the frame. Okay, and that frame, remember, what does it describe? It describes where this view is going to be in its super view when it gets added. That's all the frame is doing. Okay, and you can create it with UIView, no arguments. Then it will be 0 width, 0 height, and it'll be at 0, 0, so you won't even see it. So, but you could come along later and change its frame and or its center to move it around. Here is a really quick example how to create a view in code. I'm going to create a UI label. UI label is just a subclass of UIView. And notice that on the second line there, I'm just saying label equals UI label frame of whatever. So I'm giving it this frame 2020 150, right? And then I'm setting the text to hello. Well, if I was doing this code in a UIView controller, then I could put it at that top level view like that, view.add_subview, okay, and it would add the subview. Custom view. So why do I ever need a custom view? Either I need to do custom drawing or I need to do custom multi-touch input. Okay, those are the reasons that you're going to create a custom view. And so we're going to focus on the drawing, and the drawing is very, very simple. Okay, there's this one method that's called draw, and it takes one argument, which is a rect. Okay, for historical reasons, we sometimes call it draw rect, but it's not actually called draw rect anymore. It's called draw, and the argument is called rect. Okay, and this rect and this draw is going to be sent to you by the system. It's sent to your UIView subclass. You override it, and it gets sent to you by the system when the system wants you to draw yourself. This is the only way you can draw in your view, is to be asked by the system to draw. There is no other way to draw. Okay, in iOS. So, what's that rectangle about? That rectangle is some sub-area in your bounds that it wants you to draw. Now, that's a performance enhancement because you can ignore that and draw your whole view if you'd like. Okay, but like in your assignment 3, you're probably going to want to pay attention to this rectangle because your assignment 3's draw is going to be pretty expensive. So you want to draw as little as possible. Okay? So that's what this draw is. Very simple. It's just called by the system. Time for you to draw. It's the only way to draw. So it's really, really easy to understand. Never call this method. Ever. Okay? If you ever call this method, it's wrong. Okay? The system calls this method. The system's the only one who calls this method. So what happens if you need to draw? Something changed and you want to redraw. You call one of these two methods, setNeedsDisplay or setNeedsDisplay with the argument of a rect. And that's telling the system, hey, system, my view needs to be redrawn. Please ask me to redraw it. And at some appropriate time in the future, it will ask you to redraw it, okay? But it knows better than you when the best time to draw is, believe me, okay? And the rect that you can pass, that's just the rect that's going to be passed on to your draw, okay? So setNeedsDisplay with a rect is like an optimized setNeedsDisplay. It's like, I need to be redrawn, but only this part of me, okay? And you can send this to any UI view. Say, redraw this view. Usually views send it to themselves, though, because they're the ones who know best when they need to be redrawn, okay? All right. So how do I implement this draw with the CG rect argument guy? And the answer is you're going to do it with paths. You're going to create paths, and then you're going to stroke them and fill them to make shapes and things like that. And then you're also going to use text and images. So that's the primary way that you're going to draw in there. Okay, so we'll talk about text and images in a minute. Let's talk about the drawing with the paths first. There's really two ways to do it. One is you can get what's called a context, a drawing context, and I'll show you how to get it. And then you can send messages to that context like move to this point, draw a line to here, add an arc over here, put some text over here, things like that. Okay, actually the text we're going to do in a different way, but so that's one way. And then the other way is you can create a path object, okay, using Bezier Path. And it's the same kind of thing, but you're going to create this object that you're going to tell that object, okay, I want this path to be moving to here, and then a line here, and then an arc over to here. Okay, so you create this path, and then you send a message to that path saying, okay, stroke it. So it's a subtle difference, but you'll see. We're going to focus mostly on the UI Bezier pathway because it's kind of a little simpler. So let's understand the concepts here of core graphics. That's what the CG is that you're seeing all the places here. The number one thing about core graphics is we need a context, and that context might be a drawing context for on screen, it might be a printing context if we're printing, it might be a context to draw into an off-screen bitmap, etc. The one you care about is obviously the context to draw in your draw rect, and you get that by calling this function. This is just a Swift function, it's not on a class or anything. UI graphics get current context, and that's going to get you a context that you can then tell it to create a path by moving and all that stuff. Which is what you do then. You create these paths out of lines and arcs and things like that. Then you set drawing attributes in the context, like the colors you want to use, the fonts if you're doing text, line widths, those kinds of things. You set those all up, and then you stroke and fill. And that's it. Stroking and filling are actually the only two directives that actually cause something to happen on screen. But keep in mind that like a font is basically just a really exquisite path filled, okay, or stroked and filled. So you can do a lot with stroking and filling. So UI Bezier Path kind of encapsulates all of those core graphic concepts into an object. And so I have an example here to show you how I would use UI Bezier Path to have to draw a triangle on screen, okay? First, I'm going to create the path by just saying path equals UI Bezier Path. There are other initializers for it, which we'll see in the demo, but this one just creates a blank path to start. Then you move around with the path, so like I can say move to, which 80, 50 is like halfway across this little screen. This is a small screen, let's say, 160 points wide. 80 and then 50 down, okay? Then I'm going to add a line down to 140, 50. See that? Okay. Then I'm going to add another line over to 10 off to the left. I'm still 150 down. Then I'm going to close the path. Okay, we can close, and that just closes it back to the start. So look, I made a triangle. Okay, really easy. Now, the only thing is, all this code right here would actually draw, instead of that triangle right there, would draw this. Okay, nothing. Okay, you would see no drawing with that code. Okay, because we haven't stroked or filled it. It's stroking and filling is what draws, okay? So how do we do the stroking and fill? Well, we need to set the colors that we want to fill and stroke with. So we're going to talk about UI color in a minute, but here I'm taking green and sending it the message set fill. So you actually set your color to fill with by sending a message to color, to a color. You get a color and you send it a message, set that as my fill color, and same thing with the stroke, set as a stroke color. So I set my stroke color to red, my fill color to green. But when I'm talking about attributes like line width, I send that to the path, to the UI Bezier path. Set your line width to 3. Okay, so I do that. Now, if I say path fill, now I get a green triangle because my fill color was green, and it takes that path and it fills it in. That's what fill does. Okay, and similarly, if I say path stroke, I get a red line around because the path that I took to get around there gets stroked with a 3-point wide red line. Okay, so that's it. It's quite simple, actually. That's how we draw. Okay, and UI Bezier Path also knows how to draw a lot of common shapes like rounded rectangles and ovals and things like that, and so you should familiarize yourself with UI Bezier Path's API, of course. Another cool thing you can do with UI Bezier Path is you create a path like that triangle, and you can clip all your drawing to that path. So you could draw this elaborate picture, but only show the part that shows through that triangle. If you take that triangle path that we just created and say add clip to it. Because after that, all drawing is only going to show up inside that triangle, which is kind of cool. You can make some pretty cool effects by doing that. The Bezier path also knows how, it has this method contains that will tell you whether a point is inside the path. Okay, so that's good if you want to do some touch thing where people are touching on something and you want to do hit detection, basically what they're touching on. All right, and there's tons of other stuff in UI Bezier path. Don't have time to cover it. You should look it up. Okay, UI color. So UI color, really simple. Okay, there's some common colors like green, red, yellow, purple. Those have type methods on UI color. Remember type methods, static methods. They're on the type. You don't need an instance of it. So that's like UI color.green. But there's also initializers that let you create colors from RGB, red, green, blue, or HSB, that's hue, saturation, and brightness. You can even create a color that's made from a pattern so that when you draw with that color, it's drawing in a pattern. Okay, like a really thick line would actually be showing the details of a pattern, which is kind of fun, using UI image, which I'll talk about in a little bit. Of course, all UI views have a background color. We saw this when we did our buttons in the calculator. We made the background color of a lot of our buttons be light gray, and I'm sure in the homework assignments you made other colors. Okay, that's just a var on UIView that button inherited from UIView, and you can set it to any UI color you want. Now, an interesting thing about colors, though, is that they can be transparent or even semi-transparent, okay? And they are done, you specify that with alpha. How many people here know what alpha is when it comes to graphics? Okay, so hardly anybody. So alpha is just a value between 0 and 1, where 0 means fully transparent and 1 is fully opaque. So if you have a color, like a triangle, and you fill it with green, then if it's fully opaque, you can't see anything behind that triangle. But if it were 50%, 0.5, alpha, then you'd be able to see the green, but you'd also be able to see things behind it a little bit, 50% kind of. Okay? If it was 0, you wouldn't see any green because it would be fully transparent. You'd be looking all the way through it, so you wouldn't see any green. Okay? So you can put anywhere in that range. And the way you create a transparent color is by taking a opaque color and saying with alpha components, whatever alpha you want between 0 and 1. Okay? And that gives you a transparent or semi-transparent version of the color, and you can draw with that. However, if you draw with transparency in your UI view, you must set this var on your UI view, this is just a var in UI view, to false, okay? Because views assume that they're fully opaque, okay? And that's a performance enhancement. Turns out drawing with transparency, as you might imagine, takes a little bit of CPU power to figure out which pixels show through and all that. So by default, it assumes you're drawing fully opaque. So if you want to draw with transparency, don't forget to set opaque here to false. By the way, you can make your entire view semi-transparent by setting its alpha. So this is a var, not in color. This is a var in UIView. You can say alpha of 0.5, and your entire view will be 50% see-through. Okay? And that would work with a button or anything because those are just UI views. All right? What happens when views overlap and we have transparency in the views? Okay? Well, then that subviews that we're talking about, all the subviews of a view, starts to matter in the order. So the first thing in the subview sub 0, that's all the way in the back. And then everything else is in order in front of it. Okay? And so when any transparency that's going on is things stacked up in that order, and you're looking down through the transparency all the way up to subview 0, which is in the back. Okay? You can also completely hide a view. This is very similar, almost identical to saying alpha equals 0, which will just make the view not even appear, but it will still be in the view hierarchy. It will still be in its superview, and its subviews will still be subviews of it, but it'll all be completely hidden. And why would you want to do this? Maybe you have some UI where you don't want to show a button until the user has entered some other field or something like that, but you want to make room for the button. You want it to be ready to appear, so you leave it in the view hierarchy but hidden. Okay? All right, let's talk about drawing text. How do we draw text? Well, one way to draw text you already know is UI label. You could just create a UI label and make it a subview of your view, and bingo, you got some text in your view. Now, the only problem with that is you're drawing in your draw rect thing, you're drawing in there, and you'd have to make sure you drew, if you're drawing around the text, that it all lined up with your subview. So sometimes you want to draw in draw rect, right? You want to actually draw in there. And here, the way you do that is with a class called NSAttributed string, okay? So NSAttributed string is not a string. It's not related in any way, actually, to string. And it's not even an NS string, which is the old Objective-C style string that was indexed by ints, whereas the Swift one is indexed by string.index, unfortunately. It's neither of those. It's its own thing, okay? It's very closely aligned to old NS string, not as closely aligned to the modern string. But anyway, what an attributed string is, it's a string. You can make it out of a string or an NS string. And those characters have attributes, colors and fonts and things like that, okay? And it's very simple. You create one of these strings and you just send it the message draw at, and it will draw that string at that point as its upper left corner, okay? And you can even find out the size that it's going to need to draw it by sending the message size to an attributed string, okay? Now, one thing that's kind of bummer about attributed string is really an old style API. Var and let don't even work to make it mutable or not. Okay? So if you want a mutable attributed string where you're going to change it to attributes and change its text, you need to have a different class called NSMutable attributed string. Okay? So things like set attributes and things like that don't work on an attributed string. You have a mutable attributed string. All right? Now, you can, if you have an attributed string, mutable or not, you can get back the string that's in it as a string object using the var string, or mutable string in the mutable case. Okay? That's kind of confusing because, of course, you're used to var and let being how a string is mutable or not, but that's how you can get the string back. But let's talk about how you set the attributes. So you set the attributes just by passing in this dictionary, okay, called attributes there. You can either set attributes or add attributes to what's already there. And this dictionary is string:any. The string is just a key like this telling you what the attribute is, like it's a font or a color or whatever. And then the any is, it might be a font, it might be a color, it depends on what the key is. That's why it's an any there, okay, because it could be all kinds of things. And really important to notice here is the range. You see that range? It's not range that I taught you on Wednesday, it's NS range. Okay? NS range is an integer indexed range into that string, okay, that attributed string. Old style integer, not string.index. So this makes for a lot of trouble when you're using attributed string in the Swift world. And my recommendation to you is that you use this method, or this var rather, on string called UTF-16. UTF-16 will give you back what's called a string.UTF-16 view. That is a collection of the characters, not really a collection like characters is, but it is a representation of the string as distinct 16-bit Unicode characters, which is much more aligned. In fact, I think it's exactly aligned to what NSString does. The only problem is that thing that comes back is still indexed by string.index. So you have to say, what's the start index, offset by 5, that kind of business to move around in there. And plus, you can't pass a range of string index into this set attribute. So you have to kind of convert from string.index, how much you've advanced over, to an integer when you make these NS ranges. So I'm sorry to say it's difficult. I'm not going to actually ask you to do this in the homework, partially because it's kind of a pain in the neck. I don't want you to spend your valuable homework time working on it. But just know if you start using this that you're going to have this unfortunate disconnect. And I keep hoping every time iOS comes out, they'll come out with an attributed string, not NS, but attributed string that's matched up with string. But they haven't done it yet. It's pretty complicated to do, I can imagine. So what are some of these attributes that you can set? So there are things like NS foreground color attribute name. That's how you set the color of the text. Okay, there's also NS background color attribute name, which fonts have foregrounds and backgrounds, but don't worry about that too much. NS stroke width, so you can draw your characters really thick or thin. NS font attribute name, which you can provide a font. Okay, and there's about 15 others, and you can go look in the documentation for all of them. But speaking of font, if you want to set the font you're going to draw with, how do you do that? Well, fonts are super important in iOS. Okay? Never underestimate the power of a font in building a cool UI. Okay? Look at all these UIs. Look how important the choice of font, size, position, all that stuff is. Okay? So how do we get a good font so that our UI will look good? Well, we're going to use this very important static method in UIFont. So you send this to UIFont, the class, called preferred font for text style. Okay? And so you're going to specify the text style, which is kind of like, what's the environment you're going to use this text? What kind of text is it? And so there's about 8 or so of them. but 3 of them are like a headline. This is going to be a headline, so that's going to be a bolder font, a little larger maybe. Then body font, that's like, this is the user's data, so in a mail message, this would be the message they're actually typing maybe, although it's probably a multi-font. But, and then footnote would just be a small little text, you see, on the bottom. So I really encourage you, when you're using a font, try to find a text style that will work. Okay, because it's going to be in sync and compatible with all the other apps because they're using these preferred fonts. And also, by the way, if the user goes in settings and sets their font size to be really large, these will automatically get larger. Okay, and hopefully if you have your auto layout working, everything will expand or contract properly. Okay, there's also system fonts. Don't get confused between the preferred fonts and system fonts. System fonts go on buttons and things like that. Okay, preferred fonts are for the user's content. So that's the difference there. Now most of this stuff, again, you're not even going to set in code. You're going to set it in Interface Builder in the little inspector window. Right? You're going to be setting preferred fonts and system fonts can be set there. If you want to use a specific font like Helvetica Bold 13 point, you can do that. I don't recommend it, but UIFont descriptor is an important class to know for that. It's how you describe that font that you want, that special font. So, you know, some apps typography is what they do, and so they need to be able to do specific fonts. All right, so that's text. How about drawing images? So images, again, we have a thing like UI label. It's called UIView, and you could just make an image be a subview of your view if you wanted to have an image in there. But again, sometimes you want to be able to control that in your draw rect. And we do that with the UI image object. Okay? I already showed you actually when I was talking about failable initializers how to create a UI image. You just put it in your XC assets file, interface builder. And then you say UI image named, and it gets it by name. And if it can't find it, it returns nil. So that's the number one way you're going to get an image into your app, is put it in XC assets. But there are other ways to do it. You can get it from a file, like if you had a JPEG file. Of course, I haven't shown you how to get files, so you don't know how to do that yet. But you can do it that way. And you can also get it just from raw data, raw JPEG data or something that you got over the internet or from a URL or something. You can do that. You can even do it by drawing with all those path things. You can use this UI graphics begin image context for a certain size region. And then you can just use UI Bezier Path draw or get graphics context or whatever, draw in there. And then there's an end image context, and it'll capture it and create a little image for you. So that's another way to do it. So once you have an image, okay, that you got from any of these sources, you can just draw it inside your draw rect by saying draw at point or draw in rect. Actually, I think that's probably draw at space point, not at point colon. And draw in space rect and draw as pattern in space rect. Those do kind of what you would think, right? Draw at point draws it where that's the upper left-hand corner. It draws it in its natural size. Draw in rect is going to scale it to fit inside the rectangle that you provide. And draw as pattern is going to tile it. So presumably that's a small image and you're drawing a texture or something, and it's going to repeat it over and over to fill the rectangle. Okay? I'll fix this slide and repost it. All right, one thing to be careful of with UIView. When UIView changes size, you do not get asked to redraw by default. What it does is, believe it or not, takes what you've drawn, grabs the pixels, and stretches them to fit the new bounds. Okay, now this is often not what you want. Often what you want is, okay, my bounds change, ask me to redraw again in my new bounds. Okay, so how is this controlled? It's controlled via this var in UIView called content mode. And the content mode can be things like left, right, top, bottom, top, right, top, left. That's basically saying, take my bits and shove them up into the left corner, one of these spots, center or right. Don't do anything with them, just move them in the new bounds. Well, that's likely to cut off what you've drawn or something like that, depending on how much the bounds have changed. Like when you rotate, the bounds changes quite a bit. There's also the scaling ones, and this is the default, scale to fill. And that says, take my bits and take my new bounds and scale it to fill. I can preserve the aspect ratio if I want, although again, that's probably going to cut something off. But the real one that you want is redraw. Okay? If you set your content mode to be .redraw, then when your bounds change, your draw is going to be called. Your draw rect, draw with the rect argument. Okay? So in your assignment 3, you're going to want to do this. You can actually do this, you can do it in code by setting that var, but you can also do it in Interface Builder, okay, in the Utilities window in the Inspector for UIView. I think it's the very top one, Content Mode. All right, so I'm going to be leaving the slides here, so I will tell you what's coming up. I'm going to do this demo right now where I'm going to do a custom view, a face view, a UI view that draws a face. And then Wednesday, I'm going to talk about gestures. We'll add some gestures to control our face. And I'm going to start talking about multiple MVCs. I'll finish up with multiple MVCs next week. Your assignment 3 requires you to do multiple MVCs, so I'm not going to make it due until a week from next Monday, because you'll need next Monday's lecture. However, I'll probably ship the assignment, the write-up, on Wednesday, because a big part of that assignment is drawing your own custom view, and you'll certainly know everything you need to know to do that right off the bat, okay? So you can kind of get started on the view, and then next Monday you can start doing the multiple MVCs, and you'll still have a full week until the next Monday to get that done. All right? No Friday section this week. Okay, so as with most demos in this course, I'm going to start from scratch, okay? We're going to do a completely new app, no more calculator in here, so I could click on here to open my calculator, but instead I'm going to go back here to create a new project. Okay, it's going to be single view application, and as I told you they all would be. I'm going to call this one Face It. Okay, and it's going to start out just drawing a face, but it's going to do much more eventually. And still no core data or testing stuff yet, so I'm just going to do Face It here. It's going to say, where do you want it? I'm going to put it in the same place the calculator is in my developer. I'm not going to be using SCM, but of course those of you who came to Friday's section, you'll know how to use that. And here's my new app here, and I'm also going to do my standard thing where I'm going to take these supporting files and move them out of our way so they don't distract us every time we look at the navigator here, because we don't need those for this demo. So just like every other thing we've done, we have a view. Here's our storyboard with our view. Oops, not that small. And of course we have our controller. And I'm going to delete this out of the controller as usual here. And this time, we're going to start right off here by building a custom UI view, custom view of view subclass. Now, the way we do that is the same way we built the calculator brain. We go here, new file, right? This is how we add new files to our project. But this time, for calculator brain, we chose Swift file because it wasn't a UI thing. It didn't inherit from any iOS class. But now we're going to choose Cocoa Touch class because it's going to be a subclass of a Cocoa Touch, a UI kit class. So we click that. It says, what do you want it to be a subclass of? Okay, and we want UIView, but you can see there's other things, UIView controller and other things that we'll learn later in the quarter. But this is a subclass of UIView. I'm going to call it Face View because it's a view that draws a face. Okay, it's a good name. All right, so we click here. It says, where do you want to put it? You usually want to be very careful to put it in the same place as everything else is. You don't want it in supporting files, and you don't want it at this top level, the project level. You want it inside this folder right here that has all your stuff in it. So we'll do that. All right, so here's our face view. And you can see right off the bat in face view, we get this, which is our draw. Okay, the draw with the rect. Notice that it is commented out, and that's because for performance reasons, iOS doesn't want to ask views that don't actually do any drawing to draw because it has to keep a backing store for them, and there's memory storage and all this stuff. So by default, this comes commented out. But of course, our face view is going to draw. It's going to draw a face. So we're going to uncomment it out. Okay? Now, we have a face view here. It doesn't draw anything. But I actually want to briefly go back to our storyboard and put a face view in the storyboard. And it's really simple, but I want to show it to you. And again, if we go down to the object palette at the bottom here, where we got our buttons and labels, I could search here forever. There's no face view in here. But I can go down towards the bottom here, and you will see this one. It's actually almost at the very bottom. It's view. See, represents a rectangular region which draws and receives events, as promised. And so I can pick this guy up and drag him out, okay, and drop him here inside this view controller. Remember that the top level view in this view controller is a var called view. Okay, very important var. Now, I want this view to fill the whole space. So I'm actually going to use the blue dashed lines to make this thing fit the entire space. You see that? Now, I also want to do the control dragging to the edges that we did in Calculator. Remember that? But it's actually kind of hard to do this because I want it all the way to the edges. But since I use the blue lines, I can use a really cool feature, which is down here, this button. You see this button in the lower right here? It says Resolve Auto Layout Issues. If you click that, one of the choices is to reset to suggested constraints. So that is the system saying, I'll make your constraints for you based on what you did with the blue lines. So I'm going to look at your blue lines. Since I use blue lines all the way at the edges, if I say reset to suggested constraints, it's going to hook those things to the edges because that's what it looked like I wanted. Now I can double check what it gave me by clicking here on the size inspector. And if you look down towards the bottom of the size inspector, you can see all your constraints. And look at that. Perfect. Trailing space to super view, leading space to excellent. All exactly what I want. So here I've gotten all my auto layout with one click. Okay? And that's going to be possible to do quite a bit. If you use those blue lines and you say reset suggested constraints, often it'll at least get close. And then you can kind of tweak the ones it didn't get right. Now the other crucial thing I have to do here is that this is currently a UI view. If I go over here to this inspector here, which is the identity inspector, you can see that the class of the selected thing is UIView. Okay? So no matter what I put in my draw, it would never be called because this is not a face view, it's a UI view. But I can just click here and go down and choose face view, and now I've made this a face view. Okay? So now all the code I put in my draw is going to draw in here. And that's it. That's all I need to do to put a custom view into my UI. It's very common to want to put a custom view in the UI, so that's why it's so simple to do. Okay, so now all we need to do here is, in our face view, write the code that draws our face. So what are we going to do to draw a face? Well, I'm just going to draw the kind of emoji face, this round circle for a head, two round eyes, a little smile, okay? Very simple face. Let's start by drawing the skull of our face, the kind of the head of this face. And I just start doing that in draw here. I'm going to use UI Bezier Path to do all this, so I don't actually even need to get the context, that UI graphics get context. Don't even do that. Just use UI Bezier Path automatically knows what context you're in, so you don't have to do any of that. So what do I need to do, though? I need to kind of think of how big my face is. I want my face, if I'm in portrait or landscape, I always want my face to kind of be the smaller of the two sides, the height or the width, you know what I mean? Because I always want the face to fully fit in there. So I'm going to let my skull radius, so that's going to be the radius of my skull, okay, equal the minimum, and there's this nice min, you see that min function right there? It's generic typed, like array of t, so that's the t. It'll take any type, and it'll compare two things and return the one that's the lowest. So I'm going to get the minimum of my bounds.size.width and my bounds.size.height. Okay? And then I'm going to divide it by 2 because it's radius, not diameter. Okay? So now, see what I'm doing here? I'm just making it so that my radius of my skull will be smaller of the width or height. Okay? And then what about where I want the skull to be? Well, I want it to be right in the center. So can I say let skull center equal my center? Okay, that's a method. Can I say that? That's a bar. Anything wrong with that? No? I see shaking heads. Why not? What's wrong with that? Yeah?
This will start from the top left?
He says because it'll start from the top left. Not quite. Anyone else want to take a stab at this one? It's because center, while it is the center of this view, it's in the wrong coordinate system. Okay? This center is in my super view's coordinate system. And I'm in draw. I need to be in my coordinate system. So there's actually two things I could do here. One, I could use this cool function in view called convert, okay, which will convert a point from one coordinate system to another. So I could go down to this one, okay, convert CG point from view, and I could convert this point center from my super view. Okay? Instead of just using center, I could convert it. So that would be fine, because I've converted it from one coordinate system, my super views, to mine. That's probably a little, someone reading this code is kind of like, why are they doing that? A simpler way to do it is probably just to create a point, CG point, that is my bounds mid x, that's my middle x, see, that's an erect thing, and my bounds mid y, okay? That makes sense? So I'm just creating the point that is the center much more straightforwardly there. All right? So now I have my radius in the center. Now I need to draw a circle. So how do I draw a circle? I'm going to do that with UI Bezier Path. So I'm going to say let path equal a UI Bezier path. Now, when we look at the constructors for UI Bezier Path here, you can see that we can draw an arc, which is actually what I'm going to use. We could draw an oval, which would be cool, except for the argument is a rect, and I have the center and the radius, so I don't want to really use oval. We could draw a rectangle. I want a circle, so that's no good. Or a rounded rect. I actually want a circle, not a rectangle of any kind. Okay? So I'm going to use this one right here, which draws an arc. It just takes a center point and it draws a sweeping arc. And I'm going to draw this arc all the way around to make a circle. Okay? So how does that work? Here, I'm going to make some more space. All right, so it wants to know the center of the arc. Well, that's my skull center, right? It wants to know the radius of the arc. Well, that's my skull radius. Oh, this is easy. It wants to know the start angle. Okay, so that's the angle that it's going to start sweeping. I'm going to choose 0. The angle 0 is straight out to your right. Okay, so if you're looking at the screen, to the right, straight across, that's 0. And it's in radians. How many people know what radians are to measure angle? Okay, most of you. So radians, instead of degrees, we measure how much we're going around by radians. Radians go from 0 all the way around to 2 pi around a circle. Start 0 and then we go around pi over 2, or pi, yeah, and then pi is 180 degrees, and then around to 2 pi is 360 degrees. Okay, so it's in radians. So this end angle has to be in radians, and I want to go all the way around. So it's 2 times pi. We know that double dot pi is pi. And then clockwise is whether I'm going to draw the arc around clockwise or the other way. It doesn't matter because I'm going all the way around and getting back to the start anyway. So I'll just say false. Okay, we'll go counterclockwise. Now, I got a warning here, an error. Let's look at that error. What does it say? It says the binary operator star, and it's pointing to this little multiplier right here, cannot be applied to int and double. Okay, why is it saying that? These arguments to UI Bezier Path, the floating point arguments like start angle and end angle, what type do you think they're supposed to be? No one? I hear it being whispered. Yes, CG float. All drawing has to be CG float. So is double dot pi, is that a CG float? No, it's a double. Is 2 a CG float? Well, it might be, but Swift would have to infer that it's a CG float. And right now, Swift is confused about what that's supposed to be because it knows this argument is supposed to be a CG float, but the thing you're multiplying it by is a double. So Swift doesn't know what to infer here. Doesn't know whether to infer that 2 is a double or a CG float. So the fix here, luckily, CG float has a pi. Okay, just like double does. Now everybody's happy, because Swift knows how to interpret this literal as a CG float, and this argument to the end angle is now a CG float. So everybody's happy. It's only complaining that we don't use path yet. Okay? Excellent. So now we've got this arc going all around. Let's set something about the path, like its line width, for example. We'll set a nice, fairly thick line, 5 points wide. Okay, that's what that means, 5.0. 5 points wide. And then let's set the color. So I'm going to get UI color, let's say blue color, and we'll say set. And by the way, there's set fill and set stroke. There's also just set. Set sets both the fill and the stroke. Here we only need to set the stroke color, but I'll just say set so you learn about that one. And now I can just say path stroke. Okay, and it's going to stroke that path. So let's see what this looks like. Let's go do iPhone 7 here. So hopefully this is going to draw our skull. There we go, skull. Woo, first time. Excellent. Okay, now, I don't like the look of that very much because it goes all the way to the edges, and with a thick line, it's actually cut off a little bit. So I want to move that in a little bit, so we'll do that. Let's rotate and go from portrait to landscape. Ooh, not good, not good. Okay, why is that happening that it's doing that? Well, that's that content mode thing I was talking about, right? It's not calling my draw when it goes to this other bound size right there. So it's just scaling the bits. So let's fix both of those things. Let's make it go in a little bit, and let's fix those bits. To fix the bits, we're just going to go back to our storyboard and click on our view right here. Let's get rid of this. Okay, click on our view and go over to utilities. Okay, inspect this with the attributes inspector, and look, the very first one, content mode, scales to fill. Okay, every time the bounds change, it scales the bits to fill, and we want redraw. Okay, we could also probably use center, but I actually want redraw because if my bounds got smaller, for example, I'd want to draw my face smaller. I wouldn't want it to get cut off. Okay, so there's redraw. That fixed that one. That was easy to fix. What about making this thing kind of smaller? To do that, I'm actually going to create a var called scale. Okay, and it's a drawing thing, so it's going to be a CG float. And I'm going to set it to, let's say, 0.9, and that's going to mean 90%. And all I'm going to do is take my radius and multiply it by that scale. So by multiplying my radius by 0.9 or 90%, it should move it in a little bit, right? Kind of in from the edges by 90%. So let's see if both those things got fixed. Oh, so the 90% worked. Clearly it's in 90%. And the rotation works also. Okay? So we're off to a good start here. Everything seems to be working just fine. All right. So what's the next thing we want to do? Well, we want to draw eyes and a mouth and things like that. I want to start thinking a little bit about my internal architecture. And I'm kind of liking the idea of having some private funcs, like give me the path for the skull. Okay? And have that return a UI Bezier path that I can then stroke. And then I'll have the same thing. Give me the path for the eye. Give me a path for the mouth. You see what I mean? I'll get all these. And so I can just take this code down here that creates this path for the skull, and I'll just put it up here, and I'll just return this path. And then down here, instead of saying path stroke, I'll say path for skull stroke. Okay, you see that? Now, another thing is the skull radius and the skull center, I want all the other things like the eyes and the mouth to all be relative to that, right? So if I make my skull small, I need the eyes to get smaller, the mouth to get smaller, everything to move in. So I'm going to use these two guys. I'm going to make them, instead of being local variables in draw, I'm going to move them out and make them be private vars. Okay? And in specific, they're going to be private computed vars. Okay? So I'm just going to take what they were before, and I'm just going to return them so that no matter what my bounds is at any given time, skull radius, that var, which of course we have to type, it's a CG float, that skull radius is always going to match my bounds. Okay, because every time I ask for it, I'm going to recompute it using this little function. And same thing with skull center. I'm going to say private var, skull center, which is also a CG, no, this one's a CG point, and it's going to be computed. Return. Now, one thing you notice here, I don't remember if I covered this in the other lecture, but you notice I'm not saying get here. See, I'm not putting get and set. Okay, well, I'm not putting set because you can't set the skull center. The skull center is always the center of my bounds, so I can't set it. And if you have only a get, it turns out you don't need the get, because it's kind of redundant. So you get this kind of nicer looking code here. Okay? So now we have skull radius and skull center available to all of our methods, and so all our other paths, like path for eye and all that stuff, can use them. So let's get started on those. Let's do path for eye. How about that? So in a private func, path for eye. Now actually, probably the path for the eye is almost the same for the left eye and the right eye. So I'm going to create a little type here called eye, which is just going to be a little enum. And it's going to just be the left and right eye. So private enum eye, oopsie, eye is case left and case right. Okay? So, I mean, it's perfectly fine to use an enum to just represent something simple like this. You don't have to always be doing, methods and associated values. We don't have any associated values here. We're just representing it as a way to specify in this API which eye we want the path, the UI Bezier path for. Okay? So, by the way, also, I want to have some constants that tell me where the eye is relative to the center and where the mouth is and how big the eyes are. So to save a little bit of time here, I'm going to just type those in at the bottom here real quick. Look how fast I type them in. Okay? This is, by the way, how we do structs. or constants in Swift, we just create a struct and we make static lets on it, which are all of our constants. And what's really cool about this, one, it groups them together. Like here I have ratios. It's all the ratios between the skull, the skull radius and all these things I want to do, like the eye offset and the mouth. Also, it types them. You see, these are typed constants. I can put the type in there because they're just vars. They're static vars on this struct. Okay, we don't have any storage in this struct. Doesn't have any methods. It just is only used for constants here. Now I'm going to use these constants down here, and I'm going to use the skull radius and center up here to calculate the path for the eye. Okay, so how am I going to do that? First I need the center of the eye. Now I'm going to create a function to calculate the center of the eye, but I only need it for path for eye, so I'm actually going to put it inside path for eye. Okay, so I'm going to create a function here, center of eye. I'm typing it quick here to save some time. I'll go through it though. And center of eye, look how it's inside path for eye. And that's perfectly legal. Some of you are probably using that strategy in your assignment too. I think I mentioned it in a hint that you can do it. And all it does is it keeps center of eye inside here because it's not needed anywhere else. So now readers of my code don't have to worry about this thing being called somewhere else and what its semantics might be out there. They know that it's only used in this nice little space right here. So it's kind of a nice way to arrange your code to make it a little more readable. All right, so how does center of eye work? Well, it takes the eye, and it just gets the eye offset by taking the skull radius and dividing it by one of those constants, the ratio between the skull radius to the eye offset. That's how much it's going to offset the eye. Now, I'm going to offset the eye the same amount up as I do to the sides. Okay, so the line between the nose of our face and the two eyes is going to be equilateral triangle, or no, not quite equilateral. It's going to be a little wider, but the same distance going up as it is going out to the sides. And then I'm going to start with the eye center being in the center. I'm starting with the eye in the center of the face, and I'm going to move it up and over. Okay, so here I'm moving it up. Notice that up is minus the eye offset because decreasing y is up, increasing y is down. And for x, I'm going to add the eye offset or subtract the eye offset, depending on whether it's the left eye or the right eye. So for the left eye, I'm going to subtract the eye offset, and for the right eye, I'm going to add the eye offset. Okay? Everyone understand that little construct right there, I hope? Okay, and then it's returning the center. So now I have the center of the eye. So using the center of the eye, I can say let the eye radius equal the skull radius divided by the ratio for that one, which is skull radius to eye radius. Okay, so that's how I'm going to get the eye radius, and I'm going to let the eye center just equal center of eye, whichever eye. Okay, this is the eye that's up here. So I'm just calling this little function right here. Okay, and so I have those two things, so I can just create another circle. So I'm going to let path equal UI Bezier Path. And do that arc again. Here the center is the eye center this time, and the radius is the eye radius. And the start angle is still 0. The end angle is still CG float dot pi times 2. And clockwise doesn't matter. I'll go the other way this time. Okay, so there's my path. Let's set path line width equal to 5.0 again. Starting to get tired of typing that. It's probably not a good thing. And then let's return the path. Okay, so that's it. So that gets the path for either the left eye or the right eye. So we'll go down here, and just like we're stroking the skull, we'll say path for eye, the left eye, stroke. Okay, path for eye, the right eye, stroke. Okay, I hope everyone's comfortable with the fact that I'm calling a method, taking its return value, and immediately sending it a message. Okay, so let's see how this went. Let's see if we got this right. Oh, look at that. First time. That's really going well today. Okay, so there's our two eyes. They look good. You know what would be kind of cool, though? If we could have open eyes and closed eyes. Okay, so how could we have open eyes and closed eyes? How about this? Let's go up here, and just like we have this var scale, which, by the way, notice I left the var public, the scale, so that people who are using my face view, they can control the size of the face. I don't mind. And I'm also going to have eyes open, which is going to be a bool, which will start out being false. And we're just going to make our path for eye look at this var, look at the value of this var, and either have the eyes open or close. So I'm back here in path for I. So if the eyes are open, then we're just going to do what we were already doing here, this business, okay, because that's what we did so far. But if the eyes are closed, then I want the path to be different. So watch what I'm going to do here. Let path be a UI Bezier path without a value to start. Okay, and then I set it in here, and I'm going to set it in here, and that's allowed. In other words, Swift is smart enough to know you created a let, which can only be initialized once, but you conditionally initialized it here. Because now I'm going to say path equals, and for the closed case, I'm just going to make a Bezier path that starts out blank, and then I'm just going to move to line 2 to make a little horizontal line for a closed eye. So I'm going to say path.move to. To move to a point, CG point, we'll use this constructor right here. Not that one. Let's use this one, CG floats. And the point we're going to move to, well, we're going to move to the eye center x minus the eye radius. Okay, so we're going to move to the center of the eye and back up with the eye there. And we're going to be at the eye center dot y. So we're going to be right in the eye center, and we're going to draw a horizontal line. So we're going to move to the left side of it, and then we're going to add a line to the right side. So another CG point, which is this one again. And this one is going to be the eye center dot x plus the eye radius. And it's still at the eye center. Okay? Make sense? Some more parentheses in there. Everyone see what I did there? But I just want to make sure you understood this thing of let path. You don't have to say equals here as long as this if then still only initializes it once and doesn't change it. Okay? Because it's still a valid let. Okay, so let's go take a look at that. Okay, eyes closed. Excellent. Okay, got closed eyes. We could go back here, set this to true, run it again, and we should get open eyes. Question? So the question is, when do people do a custom view like this when they draw their own thing? In other words, when they don't use this built-in things like buttons and things like that. Well, it depends on the content that they're providing, but a lot of times maybe they're not drawing with arcs and circles, maybe they're drawing with images and text. Okay, they're laying things out how they want down to a level or in an orientation that those can't do. Or maybe they're doing text along a curve, which you can do with this, for example. So it's that kind of things. You might not see raw drawing like this. We're doing raw drawing because it's simple, and I'm trying to show you how you do it, but you know. There are apps that are drawing apps where you can trick your finger and draw, though they would clearly do this as well. Some of you might do that as your final project. Okay, so anyway, there's our eye. So we got our eyes going. We've got our skull. How about our mouth? We've got to get the mouth going, so let's go do that. We're going to do the same thing there. I'm going to have a private func path for mouth, and it's going to be a UI Bezier path. Okay, so how am I going to do the mouth? Actually, I'm going to start by drawing the mouth as a rectangle, just to show you where I'm going to put it on screen, and then we'll use a Bezier curve, actually, to make the mouth. So how am I going to do that? First, I'm going to calculate some things like the width of the mouth, the height of the mouth, and the offset of the mouth, offset down from the middle of the face, using more of these ratios. Okay, skull radius, mouth width, height. So I'm just calculating the mouth width, height, and offset. Now I'm going to use that to create the rectangle in which I'm going to put the mouth. So let's do that. Let mouth rect equal. And so the mouth rect has got to be offset down by the mouth offset, and it's going to be the width and height. All right, so let's do that. So it's a CG rect. Okay, we'll use this constructor right here. Okay, CG float. We'll do the skull's center.x minus the mouth's width divided by 2. So that's because we obviously want the mouth centered in there. And then for y, we'll use the skull center.y plus the mouth offset. And again, it's plus because plus is down, okay, in our drawing system. And the width is just the mouth width. Whoa. Width is the mouth width, and the height is the mouth height. Okay, let me make this a little easier to read. Like this. Oops. Okay, Everyone understand what I'm doing there with the mouth rect? Let's just draw this rect. So I can say let path equal UI Bezier path. Bezier path knows how to do a rect. It's this one down here. Okay? The rect is our mouth rect. And let's just return that path. Okay? So now we've got a path for the mouth. Let's go down here and stroke it by saying path for mouth stroke. Okay? Let's see what this looks like. Okay, excellent. So we have the mouth. Kind of looks like a robot face. We want it to have a nice curve, a smile or a frown. So we got to start thinking a little bit how we're going to represent whether this is smiling or frowning. And so I'm going to introduce another var up at the top here, just like I have where the eyes are open. I'm going to have a var which I'm going to call mouth curvature. I'm going to make it be a double. Okay, and I'll set it to, let's say, 1.0. And the semantics of this, I'm going to have it be that 1.0 is full smile and minus 1.0 is full frown. And this is going to be public. And this is going to be the public API that someone uses when they want to use my face view to tell me how much this mouth should be smiling. Okay, the mouth curvature right here. And I've just defined it this way. It's public. I'm documented it. And so people can set it to whatever they want. So I'm going to use this now to do it. Now, one thing is I've defined it as a double because, you know, I'm not actually doing the drawing right now. I'm just talking conceptually what the curvature is. So I need to convert this into some meaningful CG float and then use that to draw this mouth. So how am I going to do that? The way I'm going to do that is, let's get this back up here and I'll show you on the rectangle that we have here. I'm going to use what's called a Bezier curve. How many people know what a Bezier curve is? Oh, only one person? Oh my gosh. Okay, so a Bezier curve is just a line between two endpoints, but there are two other points called control points. And you can kind of think of it as the line starts out at the start, starts heading for one of the control points. As it gets close, it starts heading for the other one. And as it gets close to that one, it starts heading for the end. Okay, so the control points kind of pull on the line and give it some curve. And you can put those control points anywhere you want. Obviously, we're going to put ours like this. So my start is going to be right here in the middle of this line, and my end is going to be right here. So we're going to draw a line across here. And my two control points are going to be down here somewhere, okay, on both sides of his chin. And so the line is going to start here, start down towards this one, start going to the other one, come back up here and make a little smile. And if I move my control points up to the top, then it'll be a frown. Okay? Everyone understand that? So I need 4 points, the start, the end, and the two control points. So let's do those. Okay? So the start is easy. That's just the middle of the left edge. Okay? So I can say the start is a CG point. And again, we'll do this kind of CG point. And it's going to be the mouth rect, our little mouth rect, min x, that's the left edge, the minimum x, and mouth rect dot mid y, that's halfway up the mouth rect. And the end is going to be CG point, this float, and this one's going to be the mouth rect dot max x, and mouth rect dot mid y on the other side. So the two starting end is right in the middle of my mouth rect on either side. So now I need those two control points. Okay, for the control points, I need to think of how far down they're going to be. Okay? And it depends on the mouth curvature. The more smile I want, the farther down they need to be. The more frown I want, the farther up they need to be. Okay? So I'm going to create another thing called smile offset. Okay? And this is going to be a CG float because it's going to be something that I'm using to do drawing here. And I'm going to make it equal to the mouth curvature, equals the mouth curvature, okay, which is a double, okay, times the mouth rect dot height. So I will move down those control points all the way the entire height of a mouth rect if I'm fully smiling. Okay? Now, there's some problems with this line of code. One is, if you look at these things right here, it's saying you can't multiply a double times a float. This is a float, this is a double. So I'm going to have to convert this to a float by using a constructor for CG float. Luckily, it has one that takes a double. Okay? Another thing here is smile offset has to be between, mouth curvature here has to be between 1 and -1. So I'm going to enforce that, because I wouldn't want this mouth curvature to be 5, and now it's smiling so big that it's, on the floor, literally, jaws on the floor. We don't want that. So I'm going to use min and max to do that. I'm going to say max -1 of min of the mouth curvature and 1. Okay, and that's going to restrict it between -1 and 1. Okay, pretty got that? So I'm just using min and max to do that there. Okay, and notice that it's automatically made these be doubles, which is fine. So the result of min and max is double, and that's being converted to a float. That works fine. Okay, so now that I have that smile offset, I can say how far down my control points are. So I'm going to CP1, which is control point 1. It's going to be smile offset times the mouth rect height down, and I'm going to make the two control points be 1/3 of the way in from the edges of the mouth rect. Okay? So does that make sense? Right? We want it to kind of head down. We want it to kind of be 1/3 of the way along from each side. So CP1 is going to be on the left. That's going to be a CG point. And we'll use this again. And so this one will be the start x. Okay, the start is where we're starting right here, plus the mouth rect dot width divided by 3. So I'm going 1/3 away across. And then the y is the start y plus the smile offset, okay, which could be negative. If mouth curvature is negative, smile offset might be negative, meaning going up, and so this will be a frown, or it could be positive and it'll go down. And CP2 is almost exactly the same, so I'll copy and paste it. CP2, it's just that here we're going to go to the end and move back by mouth rect dot width, but it's the same, it's at the same level, okay, because we want it to come down, go across, and then come back up. Okay, so now that we have these control points and the start and the end, now we can draw that in the path. So we'll just go to our Bezier path right here. We'll leave the rect in there at first so we can see it. And I'm just going to tell the path to move to a CG point, which is the start. And actually, I don't even need to do that. We can just say move to the start. And then we're going to draw a curve, add curve, okay, which adds one of these Bezier curves. And we're going to the end. And the control point is CP1, and the other one is CP2. Okay? So let's take a look. All right, excellent. So we have mouth curvature as 1.0. We got a nice big old smile. Okay, we don't really want the square there anymore, it's a rectangle, so we'll get rid of that. We can just do that by creating an empty Bezier curve to start. Also, we want the pass line width to be 5.0. Okay, one nice heavy mouth. And let's go ahead and check some other things. Let's see if the mouth of -0.5, let's see if that gives us a slight frown. It should give us a slight frown, right? Indeed. Okay. All right. What's the last thing I'm going to show? One thing that's a little bit of a pain is every time I want to check the mouth curvature, I got to go run the app. Back, change it, run. Or every time eyes open, eyes close, back and forth. Wouldn't it be cool if I could just see this darn thing in Interface Builder? Okay? I can see a button when I change its things in Interface Builder. And wouldn't it even be cooler if I could have an inspector in Interface Builder that would let me inspect these things? Well, of course we can do that. How do we do that? We go up here and we just make this IB designable. Okay, if you put IB designable in front of a UIView at the top, then when you go over to your storyboard at the top, you're going to see it here, compiling that code, integrating it in to Interface Builder, and showing it to you. Okay, now, unfortunately, we don't have an inspector here that lets us inspect those things, but we can do that as well. I'm going to go back to face view here, and I'm going to say, for example, make the scale IB inspectable. Okay, let's make eyes open IB inspectable. Let's make the mouth curvature IB inspectable. Okay, let's add a few other things here. Let's make the line width IB inspectable. So to do that, we can't have this 5.0 going on over here. We're going to have to add a var. So we're just going to add an IB inspectable var. which is going to be the line width, which is a CG float. We'll start it out at 5.0, but we'll be able to change it. So now we can go everywhere where we have that 5.0. We'll just change it to use this var. Okay? We can also even do the color. App IB inspectable var, the color. It's a UI color. Okay, we'll start it out as blue, like it is now. Okay, so where we have UI color blue, we'll use this var instead, right? We have UI color blue. I'm just going to say color to set the color. Okay, so I'm basically taking all the things in my app and just making them not only configurable as public variables, but also inspectable. So let's go back to our storyboard and see if this works. Sure enough, right away, you see up at the top there, face view. Okay, the scale, whether the eyes are open, line width, the color, mouth curvature are now inspectable. So let's close the eyes. Let's have the mouth curvature be 0.5. Let's make the color be orange. Let's make the line width be 2. Let's make the scale be 0.5. Okay, make the scale be 0.9 again, whatever. Now, another interesting thing about this is just like if you were inspecting a UI button here, when you run, it's going to use these settings as the initial settings. Okay, so you truly are editing this just like you would edit anything else, any other custom view. You see it comes up like this. Got it? Now, one thing that you have to do when you have an IB inspectable, okay, is you have to explicitly type. You cannot let Swift infer it. Because while Swift can infer, Interface Builder cannot. Okay, it doesn't have an inference engine there. So always make sure you put the actual type in all the IB inspectables. Okay? All right, that's it. Next time what we're going to do is we're going to add a model to our MVC, and we're going to start putting some gestures in here, and then we'll start talking about multiple MVCs.
For more, please visit us at stanford.edu.